Hi, I'm Paul. We're doing LeetCode Must Know interview questions. Today's challenge is happy number, and it's rated as easy. So here's what we need to do. Write an algorithm to determine if a number n is happy. A happy number is a number defined by the following process. Starting with any positive integer, replace the number by the sum of the squares of its digits. Repeat the process until the number equals 1 or it loops endlessly in a cycle which does not include 1. The numbers for which this process ends in 1 are happy. Return true if n is a happy number and false if it's not. There are examples here. Okay, 19, sum of the squares is 82. Sum of the squares is 68. Sum of the squares is 100. Sum of the squares is 1. That's a happy number. Now you might think that a happy number is just something that LeetCode made up, but actually there is something in number theory called a happy number, and it is defined like this. So there's multiple ways to solve this depending on how much you know about number theory. I don't really know that much. I mean, I know that, for example, single digit numbers, only 1 and 7 are happy numbers. So if you got to a single digit number that was not 1 or 7, that is not a happy number. It's not going to turn out to be a happy number. There's other things too, but we're going to do it in a simpler way, and that is we're going to see if it loops into a cycle. How are we going to do that? Because every time we get a number via this sum of the squares process, every time we get a number, if it's not 1, we're going to put it in a set. And then we're going to continue until we either get to 1 or we get another number that's in the set, and that tells us that we're in a cycle. Okay. One thing I wanted to mention is that all or almost all of these challenges that we've done, we just wrote a method. That's it, one method. Now, sometimes, I mean, there may have been 1 or 2 where we wrote a helper method. But if you go to an interview, I discourage you from writing a solution that consists of one giant method. Okay, if you can split out helper methods, if you can write the code, in kind of a top-down way, you can even write the code where you call a method that you haven't written yet, and then you come back to it and call it. The reason I think of that in this case is because in this case, there's such an obvious case for a helper method, and that is to compute the sum of the squares. So let's go ahead and do that first. It's going to return an int. What do we need to do here? Num square sum of square of digits. Let's call it sum square digits. And the input is going to be an integer. All right, so there's a pattern that you can use with integer division and the mod operator to strip off digits one at a time from a number. So let's start with a number that we're going to use as kind of an intermediate number. Eventually we'll return this, and we'll say while n is not equal to 0, which would mean that we had stripped off and processed all the numbers. Let's say int digit equals n mod 10. All right, that'll give us the rightmost digit. Okay. And then for num, we'll add the square of digit. All right. And then we will strip the rightmost digit off of n. N div equals 10. All right. So let's see, n mod 10, that will peel off the rightmost digit, square it, add it to num, and then n div equals 10 will just shorten n by 1 digit. It'll take off the rightmost digit. Now we have a shorter n, and again, we'll just keep taking digits off of it one at a time. Eventually, we will run out of digits, and that'll be indicated by n equaling 0, and we'll return num. N will equal 0 because we'll get shorter and shorter numbers. Eventually, we'll get a single-digit number. Once we do integer division with 10, that's going to equal 0. All right, some square digits. Now, for the happy number, as I said, what we want is a set here, a set of integers. And that, we need to give it a name. Let's just call it S. S. Yeah, it's all right. Set S equals new hash set. All right. While. I don't know how many times we're going to have to go through this. I think a while true loop is the way to go here because we need an if statement in here. We're going to have to do the computation, squaring the digits, and then we're going to have to do an if statement on that. So it's really not until we square the digits that we can decide whether or not we want to break out of the loop. So I think it's better to just set the main loop as while true, and we'll break out of it. All right, let's say n, well, we're reusing the input variable, but it's not the worst. It's not the worst thing ever. N equals some square digits, and we'll pass in n. All right. Now, if n equals 1, that's a happy number. So we'll just return true. If we got a number that is already in the set, we're in a cycle. So we can return false. If neither of those is true, then we'll just add the number to the set. I'm wondering if this is going to complain that like all the paths don't have a return, but let's try it and see what happens. Compile error. What is it? There's no return. Oh, that's all? I didn't have a semicolon? Oh, I put a colon? All right. Let's do a semicolon. Now try it. Oh, it is accepted. All right, good. That is accepted, and let's submit it. Two milliseconds. Apparently 2 milliseconds for this is not very good. But I mean, I think it's well within the acceptable bound. How would you speed this up? I don't know. I mean, there may be some way to do it without the set data structure, which is kind of a heavyweight data structure, but still 2 milliseconds is not a lot. But anyway, that's it. So happy number is, can we get to 1 or do we go into a cycle? So we test for the cycle. As every time we see a number that isn't 1, we put it in the set. Well, no. Every time we see a number that isn't 1, we check and see if it's in the set. If it is in the set, we're in a cycle. If it's not in the set, we add it to the set and we keep going until we either find a cycle or we get to 1. And that's it. Thanks for watching. Feel free to like, subscribe, comment, and see you next time.